Is this a feature or capability that customers can take advantage of immediately, or do they need a certain, number of cycles of, gathering that information and, the machine really consuming that information before they can take advantage of these types of insights?
People sort of take a look at, okay, machine learning, predictive analytics, whatever you want to call it. They say, yeah, this is great, but where do I get started? And do I have enough data? Do I have enough sophistication inside my company to take advantage of this? And one of the things that we are doing that is fundamentally different is we want finance people to use the machine learning capabilities in the context of financial planning, in the context of financial forecasting. What we are building is not for data scientists, it's really for finance people. So a fundamental difference, right? I mean, I can throw a Google forecast algorithm or an AWS forecaster algorithm at somebody and say, go generate your predictions. But how many people in finance are comfortable with this? I mean, it'll come up, the first set of questions it'll ask you is, what algorithm do you want to use? I have no idea.
Yeah.
I have no idea what algorithm do I want to use. So the way we are building this is really the system will look at the shape of the data, the amount of data you have, what that looks like, and then pick the right algorithmic choices for you. Yes, as you go up in sophistication, you can override some of those choices or fine-tune some of those choices. But to get started should be very simple, number one. So I think forecasting is often a good first sort of problem in the use of machine learning, but not always. I mean, there are people that start in other areas related to operating expenses, for example, travel expenses, pre-COVID at least. Travel expenses could be, and post-COVID also. During COVID, it was very easy to forecast travel expenses, zero. Right? But anyway, travel expenses as a line item, for example, is very amenable to sort of machine learning or data-based modeling. So pick easy items like that. What I always sort of suggest to customers is don't just pick one area, pick a couple of areas, a couple of line items for machine learning based predictions. And also don't set the bar impossibly high. What some of my customers do is, okay, my human forecaster with all his or her collective years of experience is able to forecast with 75% accuracy, let's say. The minute I say I'm building a machine learning model to predict that line item, they expect 95% plus. If I deliver 85%, they say, oh, this is a failure. I improved it by 10 percentage points over your human forecaster, but people keep expectations unrealistically high. So what I tell them is, keep expectations realistic. Pick 2 or 3 areas and get people involved. Get the finance people involved. Don't just give it to a data scientist and have them go build an experiment on this. Get finance people involved. That's when you build expertise, you build familiarity. You also build trust and confidence in what the machine learning model is doing. Because at the end of the day, finance people are different than marketing people. Marketing people, since Google over the last 20 years, they've gotten very comfortable with black box sort of models. So if I give a marketing prediction, the marketing guy is more willing to accept a black box model. Whereas finance people are, show me. I need to understand the model. I need to understand not just what it is doing, but why it's doing it. So one of the things that we are doing to create that trust and confidence with finance people is this concept of explainability. So we not only build a model that is good at prediction, we also build models that are good at explaining why they predicted what they predicted in terms that human beings can understand. So we'll say, these are 4 factors that went into the prediction that I made. And this is the dominant one. This is the second most important one. This is the third most important one. And that may change over time, right? My pricing may be the most important predictor of demand in one situation. The macroeconomic condition may be the most important factor in predicting demand under a different set of circumstances. So at a given point in time, when I make a prediction using the model will say, these are the factors in relative order of importance. And the finance guy takes a look at it and he or she will say, yeah, that makes sense. And if it makes sense, you accept it. If it doesn't make sense, then you say, you know what, you go to a data scientist and say, you know what, this is not making sense. There's something off here. Let's talk about it. So that sort of thing. Sorry about the long answer, but hopefully it gives you
I think clarifying that why, that also helps the planner, right, understand what they're missing. Maybe something was buried. And so I think that helps the future planning processes and sophistication going forward, right?